So as I said, while we're waiting for people to fill in, we'll start out with a little bit of review here. You should have your Unit 3 test back now. If you don't have it back, check with your teacher at your location. I've actually got a few of the corrections back already, which is great. Remember, if you haven't done those yet, do corrections. Again, ask me if you want to. If we need class time to go over any of them, let me know. I will also be posting on Blackboard an alternative version. So that's going to be an alternative Unit 3 test. And if you do that alternative version of the Unit 3 test, you will get back an additional. What will happen is I will average that score as long as it's higher than your other score. I will average that score with your previous test score. In fact, let me post that right now. So you still get to do corrections, and then you also have this where you can redo it without having the time limit. You'll do it on your own, print it off, take it home. Work together if you need to. I want to make sure you guys are confident in these dosage calculations. I realize we kind of did them inside out and backwards so that you have all the different possibilities, but it's an important. It is the most important unit of the course in my mind, so I want to make sure you have a chance to do those again. So download that from Blackboard and submit it through your teachers there. They'll scan it and send it to me for you. Like I said, let's say you ended up with, I'm going to go on the low end here. Let's say you had 60% or 60 points on your previous test, and you do this alternative test. Let's say you get 90 points on that. Well, average together, that is 75. If you then do corrections on that previous test, you will still get back your 20 points corrections. So that puts you sitting at a 95 score for that test. So, I mean, I realize that's really padding your score, but that's how important I think this is to make sure you go through those dosage calculations. So it is posted on Blackboard right now for you. It should be towards the bottom of the list. Please download that and complete it and have it submitted to me. So again, just give you another look at them and hopefully raise your scores for you. Okay, so anyway, we've been talking about graphing in Unit 4. And like I said, we will be finishing up Unit 4 either this Friday or the following Monday. So Unit 4 test will either be Monday or Wednesday of next week. So anyway, graphing, we've been talking so far mostly about graphing lines. And with those lines and segments of lines, we've talked about slope, y-intercept. That was our main form of equation, by the way. Y was equal to your slope times x plus your y-intercept, which we abbreviated as b. But then we also did formulas for midpoint and length or distance. So either the length of a segment or the distance between 2 points on whichever stance you are looking at it. When we graph those lines, we use that slope intercept form, that y equals mx plus b. We would take an equation, draw a basic graph here, like y equals 5 minus 2/3 x. And our starting point was always the number that was not multiplying the variable. So the 5 here is not multiplying the variable. It is a positive 5, so we start out up 5. That was our first point, our intercept. Then the slope multiplied the variable. We have to be careful here. That is a negative 2/3 multiplying the variable. And we went down 1, 2, because our rise was a negative 2. And then we ran 1, 2, 3. That's our line. So that was our graph. Well, we had another form of these equations that we talked about called point slope form. And I want to review that for just a minute today because that point slope form relates to how we graph other forms of equations a little bit better than that slope intercept form. So in that point slope form, remember instead of having an intercept, we weren't given a y-intercept. Instead, we were given a point. We were given a point we call x1 and y1. So then the form of our equation was y minus y1, that point, the y coordinate of that point, is equal to our slope m times x minus x1, that x coordinate of that point. So if I have an equation that looks like this, y minus 3 equals 1/2 times x minus 2. I can find, instead of an intercept here, I can get a starting point, that x1, y1, out of this equation. X1, of course, is the number that is subtracted from x. That would be 2. Y1 is the 3. So that's telling us this equation the graph of this line starts at the point 2, 3. So I go over 2, up 3, right there is that point, 2, 3. From that point, then, my slope applies, which is the 1/2. So from that point, I go up 1 and over 2. There's my second point. My line goes through those points. So let's look at least one more example of that. Let's say I have, let's just scroll down and get a new graph here. Y plus 1 equals negative 3/4 x minus 4. Little trickier here because this is a plus. And remember, the form of the equation is y minus. Anyway, our x coordinate here is going to be 4. The y coordinate is the one that's confused because that's plus 1. Since it's always y minus y1, what that really is y minus a negative 1. Remember, subtracting a negative is a positive. So that is negative 1 is the y coordinate. So to graph this starts out at 1, 2, 3, 4 for x, negative 1 for y. That is the first point on this line. And then the slope being negative 3/4. From that point, we go down 3 over 1, 2, 3, 4. There is our second point on the line, and we can draw our line through there. The reason I wanted to show you this is because this is the way, the shortcut for graphing many of our other forms of graphs are. There are parabolas that use this form. We'll look at that in a little bit. There are absolute value equations. Cubics follow that form. In fact, most of our standard shapes follow this type of form. Now we can get into polynomials, which are much different. All these are forms of polynomials, the parabolas and cubics. When we get into higher order polynomials, there's a lot more variables involved rather than just locating a starting point. Today we want to look at the parabolas. Now we're going to start out with graphing form. And we're just going to look at it briefly because it does kind of follow from that point slope form from our linear equations. However, most of the time when we're given a quadratic equation that forms a parabola, it's not given in graphing form. And we're not going to take the time in this course to go ahead and show you how you would take it from a standard form to a graphing form. Involves something called completing the square, which would have been in an Algebra 2 class, or you would see it again if you go on to a college algebra or intermediate college algebra course. So anyway, graphing form looks exactly like it did up here for the point slope form of the equation. We have a point x1, y1, that is the starting point. It's actually called the vertex of that parabola. Remember, a parabola is shaped kind of like a U. The vertex is that point where it goes from going up to going down, or from going down to going up, depending on which direction it opens. So the graphing form of a parabola is y minus y1 equals, now I'm not going to call it slope here, I'm going to just use the letter A, which kind of gets into, it's not the eccentricity, but it's related to it. What it is, it describes how wide the parabola is and how steep the sides are, is equal to x minus x1. Now again, right now we're not going to get too much into what this A value means because we're not really going to focus on this graphing form. But let's just take a peek at one equation that starts out in that form. So I'm going to do y minus 3 equals, and I'm just going to put a 2 in here, times x plus 1. So our starting point, x and y. Well, remember, it's x minus x1. So technically, x plus 1 is x minus a negative 1. So that x coordinate is negative 1. The y coordinate is 3. So our vertex is at negative 1, 3 right there. Now next is this 2 that tells us two things. One, it's positive, so it means it opens up. Our parabola is faced like that. And 2 is bigger than 1, which tells us it's slightly steeper than normal. Think of it as a slope. If you go over 1 unit in each direction, you go up 2 at the first step. Now after that, it goes steeper because it is parabolic, but you get this upward opening parabola like that. So the big advantage of this graphing form is you can very easily locate the vertex. But from there, it's actually much more difficult to graph. So let's go back and take a look at one of these parabolas in standard form. So standard form would look like this. Y equals x squared plus, let's see here, 4x minus 5. To figure out how to graph this, we're going to have to do a little bit of an algebra review. If you remember back in the very end of Unit 1, we talked about solving equations. And we also talked about combining or operations with algebraic numbers. But one of the things we did was we multiplied algebraic numbers. And there was a couple of different types of multiplication we did. We could do a single digit number times a multiple digit number, like 3x times 5x minus 7. When we multiplied that, we distributed. 3x times 5x was 15, x squared. 3x times negative 7 was a negative 21x. Well, we want to look at how do we reverse that process? In other words, something called factoring. How do we factor that? Factoring, very similar to numbers, whole numbers, we're looking at numbers that divide into that. If I asked you to factor, and we often use the term prime factor, let's do one that's not quite so easy. Let's say 60. Well, you might look at 60 and say, hey, it ends in 0, so I know 60 can be divided by 10. Well, 60 divided by 10 leaves us with 6. We factored it. It's not prime factored yet. We can keep going. 10 can be split up into 2 times 5. Those are prime. They can't be split anymore. 6 can be factored into 2 times 3. Again, those are prime. They can't be split up anymore. So factoring 60, it's 2 times 2 times 3 times 5. Well, when we're doing factoring on something like this, 15x squared minus 21x, we're looking at the same thing. We're trying to divide it out. To divide it out, we are looking for common factors. We have 15x squared and 21x. First thing we want to look at is the numbers, 15 and 21. Think of reducing a fraction. If we were reducing a fraction, if that were 15 over 21, what is the largest number that both of those can be divided by? Well, both of them can be divided by 3. 15 divided by 3 would be 5. 21 divided by 3 would be 7. Could they be divided by anything still? Well, no, both 5 and 7 are prime. So 3 numerically is the greatest common factor of that, of 15 and 21. Now we look at the variables. We have x and x squared. If we look at those, the biggest thing that either of those can be divided by, well, they can each be divided by x. X divided by x is 1. X squared divided by x would be just x. When we're looking at variables, by the way, the common factor is always the smallest power. So this is x squared. Think of this as x to the 1. 1 is smaller. So x is, for the variables, our greatest common factor. So the greatest common factor of these two digits, the 15x squared and the 21x, technically negative 21x, is 3x. Now, just like we did here, we found that 10 was a factor. We divided to see what was left over. 60 divided by 10 gave us 6. Well, here we're going to do the same thing. We're going to divide by that 3x to see what's left over. 15x squared divided by 3x. Well, 15 divided by 3 is 5. X squared divided by x gives us x. Negative 21x divided by 3x. Well, negative 21 divided by 3 is negative 7. X divided by x cancels out. So we have factored that. So 15x squared minus 21x is 3x times 5x minus 7. Well, we did that multiplication to get the 15x squared minus 21x to begin with, so we know that's correct. But what if we didn't have those pieces to start with? What if we weren't the ones that multiplied it out? Well, let's say that we have, let's see here, 35x squared plus 21x. If I look at this, I start out with the 35 and the 21. The largest number that divides both of those, let's try 7. 35 divided by 7 is 5. 21 divided by 7 is 3. Can I reduce those any further? No, I cannot. So 7 is the greatest common factor of the numbers. Now again, we've got x squared and x. We use the smaller power, which is just the x. We divide out the 7x. 35 divided by 7 is 5. X squared divided by x is x. So 35x squared divided by 7x is 5x. 21x divided by 7x. 21 divided by 7 is a positive 3. X divided by x cancels out. So there we go. We factored that. So that would be the first thing we would always look for in trying to factor an equation. Unfortunately, that's not the most common needed method for factoring an equation. More common than that is reversing our FOIL process. Now, we threw FOIL out there, but I also showed you it can be done with long multiplication. But let's review what FOIL was. We could have something like x plus 2 times x plus 5. The F in FOIL stood for first. We multiplied the first digit in each number. X times X was X squared. So that's from the F. O stood for outside. So X times 5 is 5X. That's our O. I stood for inside. 2 times X is 2X. So that's I from the inside. Next, we're going to do the last. The last two digits, 2 times 5 is 10. Now we have to combine the 5X and the 2X because they have the same name. They're like terms. So we have X squared plus 5X plus 2X is 7X plus 10. Well, as we look at this, we realize that the X squared is from the first digits, the F. The 7X, that's from the outside and the inside. We'll come back to that. And the 10 is from the last digits. So if I were going to factor that, I would start with this X squared and with the 10. I know if I were going to split this back up, it's a 3-digit number or trinomial. It's going to split back up into 2 binomials being multiplied together if it can be factored. So binomials means there's 2 digits in each. And I know that this first digit here, the X squared, comes from the first digits of the original binomials, the original numbers. Well, X squared, the only way to make that is X times X. We could have X squared times 1, but that wouldn't make much sense here. Next, we know that the last digits, the second digit in each, those two have to multiply to make the 10. So that means it can either be 2 times 5 or 1 times 10. How do we know which one's right? Well, in this case, we multiplied it out to begin with, so we know it's 2 and 5. But let's put them in there, and I'll show you how we double check. To figure out which one is right, we do just guess one, and then we double check. We know that this middle digit, the 7X, has to come from the outside and the inside. So we guess the 2 and 5, and then we check. On the outside, we have X times 5 is 5X. On the inside, we have 2 times X, which is 2X. 5X plus 2X is 7X. Now we're going to stick to some relatively simple trinomials to factor here. So you might recognize some patterns and shortcuts. That is wonderful if you see that. Some of those patterns, as you got into more complex ones, you might have to do a little more thinking and trial and error. But with these simple ones, there are going to be a lot of patterns that you can see. So let's go back to the example we had up there, y equals x squared plus 4x minus 5. What we're trying to factor here is x squared plus 4x minus 5. So it's 3 digits. We know it's going to split into two-digit numbers or 2 binomials. And we know these first 2 digits have to multiply to make this first digit. Well, x squared would be made by multiplying x times x. We know the second digits have to multiply to make this last digit of the original polynomial, negative 5. Well, 5 can only be made as 1 times 5. So the negative 5 is either negative 1 times positive 5 or a positive 1 times negative 5. How do we know which one? Well, we try it. And again, some of you may start to recognize some shortcuts. I'm purposely choosing the wrong one here, but let's see, we're going to do positive 1 and negative 5. Well, that's why we double check to see if that inner digit works. Remember that 4x is to be a combination of the outside and the inside multiplications. So on the outside, we have x times negative 5, which is negative 5x. On the inside, we have 1 times x, which is 1x. Negative 5x plus 1x is negative 4x. Now, at first glance, that looks promising, but we had positive 4x. So that is not quite correct. What that's telling us is we need to change the signs. Instead of positive 1 and negative 5, Let's do -1 and +5. So now on the outside we have x times +5 is +5x. On the inside, -1 times x is -1x. That gives us 4x. So the question becomes, how does this help us graph this? So let's go back to this original equation. This factors into that. So we can have y equals x minus 1 times x plus 5. As we look at a graph, we looked at y-intercept for a linear equation originally. There's also x-intercept. X-intercept, of course, would be where it crosses the x-axis here. For a quadratic equation and polynomial equations, those x-intercepts are referred to as roots. Well, the x-intercepts, those roots, occur where y equals 0. You can see at any point on the x-axis, the y-coordinate has to be 0. So we go back to our original equation here. To find the roots, we let y equal 0. The reason we had to factor this now is once this equals 0, now this becomes basically two linear equations that we can solve to find the roots. A parabola will have two roots if it crosses the axis. There are some that don't cross the axis, they have no roots. That's beyond the scope of what we're going to cover here. So we talked about our zero product rule a little bit in the second week of the class. The zero product rule being that any number times 0 equals 0. Well, there's another form of that rule that says if two numbers multiply to make 0, then at least one of them has to be 0. So if a times b equals 0, then either a equals 0 or b equals 0. Or it's possible that both equal 0. So up here, what that's telling us is x minus 1 times x plus 5 equals 0. So that means either x minus 1 equals 0 or x plus 5 equals 0. And we can solve that for our roots. So here, solving this for x, we would add 1. We get x equals 1. Or over here, solving for x, we'd subtract 5. X equals -5. So what that means is on our graph, we have roots at x equals +1 is right there. That's a root. And x equals -5 right there is a root. So those are our two roots. Now, as we look at a parabola, there are some definite features of those parabolas. We saw the vertex when we did the graphing form. That vertex is where it went from going down to going up. That vertex, if we're looking in terms of the roots, is located exactly between the roots. In fact, it's located on something called the axis of symmetry. To find the axis of symmetry, since it's going to be exactly between the roots, we just look at for the average of the roots. So we have roots at -5 and +1. The average of those, -5 plus 1 over 2. Make sure you hit equals before you divide by 2. -5 plus 1 is -4. Divided by 2 is -2. So that axis of symmetry is here at -2. Looks like that. Well, how does that help us find the vertex? Well, that just told us that the x-coordinate for the vertex is -2. How do we find the y-coordinate? We go back to our original equation. Y equals x squared plus 4x minus 5. If x equals negative 2, y equals negative 2 squared plus 4 times negative 2 minus 5. We put in the negative 2 for x. Negative 2 squared is positive 4. 4 times negative 2 is a negative 8 minus 5. 4 plus negative 8 is a negative 4. Minus 5 is negative 9. That is the y coordinate of our vertex. So we would count down here 1, 2, 3, 4, 5, 6, 7, 8, 9. That's our vertex. Now, we probably could just go ahead and draw our parabola from the vertex through those roots if we wanted to. And for this course, that's good enough. If you wanted to, you could pick other points. This kind of goes back to those tables we made. You might pick x is negative 1 or maybe x is 0 and see what you get. If x is 0, it'd be easy. Put 0 in here, y has to be negative 5. So x is 0, y is negative 5. One of the advantages to the axis of symmetry is we know there's another point on the opposite side of the axis in the same location. Let's do a full example of graphing that without all the little sidetracks. So let's graph y equals x squared minus 2x minus 3. So we need to find the roots. To find the roots, we need to do two things. We need to factor this, and we need to make y equal 0. So let's factor this. So we know that the first numbers multiply to make the x squared. That's just going to be x times x. We know the second numbers are going to multiply to make a negative 3. So it's either negative 1 times positive 3 or 1 positive 1 times a negative 3. Now, if you look at this, some of you may have picked out patterns already. You know they have to add up to this middle number. So you say, well, maybe the negative 3. Let's try it. So positive 1 and negative 3. Let's check on the outside and see what we get, outside and inside. So on the outside, we have x times negative 3 is negative 3x. On the inside, we have 1 times x is positive 1x. Negative 3x plus 1x is negative 2x. That's what we want. So this is our factoring right here. X plus 1 times x minus 3. So our roots then are at x plus 1 equals 0 or at x minus 3 equals 0. We solve this one by subtracting 1 to get x equals negative 1, or solving this one by adding 3 to get x equals positive 3. So up here we've got negative 1, there's a root, positive 3, there's a root. To find our axis of symmetry, we look at those roots, we average them together. Got negative 1 plus 3 divided by 2. Well, negative 1 plus 3 is just 2. Divided by 2 is 1. So our axis of symmetry is here at x equals 1. So if x equals 1, our vertex is on that line, we go back to our original equation right here, and we put in x equals 1. So instead of y equals x squared, y equals 1 squared. Minus 2x becomes 2 times 1, minus 3. So 1 squared is 1, minus 2 times 1 is 2, minus 3. 1 minus 2 is negative 1. Negative 1 minus 3 is a negative 4. So y equals negative 4 and x equals 1 is our vertex. So again, x equals 1 is our axis of symmetry. We go down to y equals negative 4, there's our vertex. We can graph our quadratics. One more example. So y equals x squared plus 10x plus, oops, 21. So we're going to graph this. Again, we defined our roots first. We're going to let y equal 0, and we're going to factor this. We know that x squared is x times x. 21 can either be 1 times 21 or 3 times 7. It's positive, so they're either both positive or both negative. So that means it could be negative 1 times negative 21 or negative 3 times negative 7. This number is positive, it's positive 10. So chances are it's not going to be one of the negative options. So let's try the positive option. Let's try positive 1 and positive 21. If I try that on the outside, x times 21 is 21x. On the inside, 1 times x is 1x. That adds up to 22x. That is not what we want. So the 1 and 21, not a great option. Let's try 7 and 3, or 3 and 7. So x plus 3, x plus 7. And we'll check it. X times 7 is 7x. On the inside, 3 times x is 3x. 7x plus 3x is 10x. That's what we wanted. So here's our factoring right there. So now that tells us that either x plus 3 equals 0, or the other root's at x plus 7 equals 0. So we go to solve each of these. This one we subtract 3. X equals negative 3. Or over here we subtract 7. X equals negative 7. So we're going to put those roots on our graph. So we've got negative 3 is right here, negative 7 is right there. Our axis of symmetry, again, is found by averaging those roots. Negative 3 plus negative 7 is negative 10. Divided by 2 is going to be a negative 5. So axis of symmetry is right here at negative 5. We define y. So y is going to be found by putting negative 5 in for x. Negative 5 squared plus 10 times negative 5 plus 21. Negative 5 squared is positive 25. Positive 25. 10 times negative 5 is a negative 50 plus 21. 25 plus negative 50 is negative 25. Negative 25 plus 21 is a negative 4. So y equals negative 4. So 1, 2, 3, 4, there's y right there. And that gives us our parabola. Should have gone through the point a little better here. There. Now, we have this factored form. When we found x equals negative 5, I've been putting it back in the original equation, but we don't have to. For some of you, it might be easier to use this factored form. You might look at that and say y equals x minus 3 times x minus 7. Sorry, not minus, plus. And you might say it's easier to put that negative 5 in there. So y equals negative 5 plus 3 times negative 5 plus 7. Doing each set of parentheses first. Negative 5 plus 3 is a negative 2. Negative 5 plus 7 is a positive 2, and that multiplies out to make negative 4. So that might be easier to put it back into that factored form. Okay, we're almost out of time here. So your homework, there is a worksheet posted on Blackboard. The worksheet contains these quadratics and it contains parallel and perpendicular. On that worksheet, just I want you to do 1 through 6, which is graphing these parabolas. Now, if you get stumped on any of these trying to graph them with factoring, you can always go back to a table, pick a value for x, and calculate what y has to be and just plot points. This factoring and finding those roots is just a shortcut for finding points that are easier to graph, that are more meaningful to the graph. But if you struggle with that little bit of factoring and the roots and the axis of symmetry and stuff, you can always go back to just plotting points in a table. Anybody have any questions? Okay, well, that is it for today. So we'll see you all on Wednesday. You guys have a great day.